of the persons buying petrol, it says that 40% are females, and of the females, 30% pay for their petrol with cash, and of the males, 65 pay for their petrol with cash. Copy and complete the following tree diagram. So as you can see from this tree diagram that we're seeing here, you have two people paying for petrol. You have females and you have males. All right, females and males. All right, and females, they're paying with, let me use a different color here. Females and males, they're either going to pay with cash or they're going to pay with something else. That's probably credit card. More than likely, it's credit card or debit card, something along that sorts. All right, so this is females and this is males, and 40% are females, so that's 0.4. So 60% are males, that's 0.6. All right, next thing now is that how much pay with cash? Let's call this cash. All right, let's call this cash. Now, he told us that of the females, 30% pay with their cash. So 0.3 pay with cash. So that means a 70% pay with other. All right, 0.7 pay with other. All right, and then for males now, it says 65% pay with cash. And so that means 35% pay with other. $65% pay with cash. Nice and easy. Now it says, what is the probability that a customer pays for petrol with cash? Now the probability the customer is going to pay, so probability the customer going to pay with cash, let's work that out. I'm going to call cash C. Let's just call it C. The probability the person is going to pay with cash, I'm calling it C. The probability of the person paying it with cash, it can either be a female and paying with cash, so it can be 0.4. Probability of female times cash, 0.3, plus it can be a male that is also paying with cash, so that's 0.6 times 0.65. That will give you the probability of a person paying with cash. So 0.4 times 0.3 plus 0.6 times 0.65, that's 0.51. All right, so that is, there is a 51% chance, there's a 51% chance a person pays with cash. All right, so 51% chance a person will pay with cash. Now, what is the next part of the question? The next part says, determine which is more likely event. Which is more likely means which of these have a greater probability of occurring. All right, which of them have a greater probability of occurring? Now let's look. It says, customer is a female given that petrol is paid with cash. So let's check out event T. What's the probability of event T happening? All right, let's work that out. The probability of event T occurring. All right, but what is really event T? Event T is the probability of customer is female given that petrol is paid with cash. So the probability being female given that petrol is being paid with cash. All right. So now the probability of being a female and paying with cash, that's going to be equal to the probability of F intersect C, that's the probability of being a female and paying with cash divided by the probability of paying with cash. All right, so the probability of being a female and paying with cash is 0.4 times 0.3. That's the probability of being a female and paying with cash. And that's now divided by the probability of a person in general paying with cash, which is 0.51. So now what is that? 0.4 times 0.3 divided by 0.51. That's 0.235. This is 0.235. That's the probability of event T occurring. That's the probability of event T occurring. So now let's say the probability of event V occurring, which is a male customer who does not pay for petrol with cash. So the probability of V, which is a male customer who does not pay with cash. So the probability of being a male customer, so this is a male customer and what? And don't pay with cash. Probability of being a male customer and don't pay with cash. So we said cash is C, so the probability of M intersects C. So the probability of being a male customer and don't pay with cash is 0.6 times 0.35. All right. What is 0.6 times 0.35? So 0.6 times 0.35 is 0.21. So there's a greater chance of a customer being female given that they pay with cash. All right, so there's a greater chance of event T occurring. So let's write the conclusion. Always finish with your conclusion. Don't just work out and don't tell them what are you concluding. Give them the conclusion. So event T is more likely to occur. So that is, there is a greater chance of a female. There's a greater chance customer is a female given that the petrol is paid with cash. Nice and easy. Soft. Now we move on to part B of this question. Part B gives us some marks, right? And it says, state one advantage of using stem and leaf versus a box and whisker to plot the display of the data. So we want to state one advantage of stem and leaf over the box plot. So the stem and leaf, it displays all, how can I say, it displays all data points where the box plot, the box and whisker or box plot only displays the summary statistics. So the box plot, it only displays the median, the upper quartile, the lower quartile, all right, and it also displays the upper hinge and lower hinge. Those are all the box plot display. And we can say as a result, we are unable to find mode and mean from a box plot, but we can compute mean and mode from a stem and leaf diagram. So this is one advantage of the stem and leaf above. This is one advantage of the stem and leaf. So now the next part of the question says, construct a stem and leaf diagram to show the data. So I want to construct a stem and leaf to show the data. All right, so I'm just going to write out all the data. It makes it easier right here. So just rewriting all the data. As we see, it's 58, 92, 41, 89, 72, 66, 51, 63, 80, 40, 69, 45, 83, 76, 53, 56, 75, 50, 99, 50, 85, 63, 58, 75, 66, 56, 81, 74, 51, and 94. Now, one thing before we even continue, I just want to say this student that got 99 on an English exam is fantastic. I don't know what kind of student gets 99 on an English exam, but that student is exceptional. So let's construct our stem and leaf diagram. So this is the stem. All right. But over here be the stem. And over here be the leaf. All right. And so, of course, we'll put our key later down. Okay. So, of course, we have to start from, we need to, is there anyone in the 30s? Anyone in the 30s? Just to be safe, I usually write 3, 4, 5, 6, 7, 8, 9. Just to be safe. Is there anyone in the 30s? It's good to do that. Anyone in the 30s? No 30s here. No 30s. Anybody in the 40s? I say 40, so we can put a 0. So underline this 40. This is out of the way. I see a 41, so we can put a 1 here. Get this one out the way. Let me change the color so I'm not confused. I want it in order. Is any other 40? Let me see. No more 40s. No more. There's a 45 here. So this is the 45. We can put the 5. Let's go in the 50s now. Anybody with 50, of course. Somebody after Bailey pass, that's 50. When we look again, there's another 50. Somebody, this person scraping the pass mark, the Bailey scraping. Right, scraping, scraping. This is 51, scraping. Like it's bottom of the porridge, 51. All right, and we're gonna look for 52. Is there any 52? I don't see any 50. This is another 51, another scraper. Right, 52, any 52? Can't see any 52. So I'm gonna assume that the next one is 53. Here's 53. No more 53. 54. No 54. 55. 55 should be here. 55. 55. 55. Don't see any 55. 56. Here's a 56. You can put 6 right here. See another 56. Here's another 56. And put another 6 here. Then it asks for, let me see now, 57. No 57, but I see 58. And put my 8 here. And I see another 58. And I can put another 8 here. All right. And then now what else now? 59. 59. No 59. No 59. That's crazy. Let's go for 60 now. Where is 60? 60 is there any 60? No 60. So no 60. I say a 63, however. I see a 66. And I see a 69. You know, going into the 70s. Going into the 70s, going into the 70s. Now we see a 72. And this is a 74. And let's see a 75. And let's see a 75 here. And what else now? Here's a 76. Need a 77 now. How do I find 77? No 77? No 77. And here I missed out. Oh, I missed out a 63 here. So it's a good thing I was looking back. So I missed out some 63s. Another 63 was supposed to be here. Here it is. And a 66. So it's 266. And then the 69. Good. Now we're into the big boy territories, the 80s. So we have a 81. Let's speed it up now. We get the process. We have a 80. So we have 80. We have a 81. Here's the 80. Here's the 81. We have a 83. Then we have a 85. Then we have a 89. Then we're going into the 90s now. In the 90s, we have 92, we have 94, and of course, we have this magical English student that got 99. I don't know how. That's that. This should be 30 grades. Just check it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 20, 29, 30. So we're good. 30. So that's the stem and leaf. It says determine the median mark. So the median is Q2. So the median mark Q2, the median occurs midway at the, it's going to be the 15.5 position. That's the median, 15.5 position. All right, so 15.5 position is going to be in between. Let's go there. 15.5, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the median is in between here. So the median Q2 is equal to 66. That's the median. That is, the median is 66. Then it says now, calculate the semi-interquartile range. First and foremost, the semi-interquartile range is going to be equal to the interquartile range divided by 2. That's semi-interquartile range. Interquartile range divided by 2. That's semi-interquartile range. All right. And so to find the interquartile range, it's going to be Q3 minus Q1 over 2. Q3 minus Q1 over 2. All right, so let's find Q3. Now, the position of Q3 is going to be 3/4 of n plus 1. So it's going to be 3/4 of 31. And that's the 23rd and a quarter term. So let's go there. All right, so 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's going to be the 8th term from here. 1, 2, 3, 4, 5, 6, 7, 8. So this is Q3. Q3 is 80 minus Q1. Q1 is the 8th term from here, which is 1, 2, 3, 4, 5, 6. So we're going from here. All right. So we're going from here. So with here now, we're going here. 1, 2, 3, 4, 5, 6, 7, 8. So this is what I'm getting for Q1. Q1 is 53. So the semi-interquartile range is 80 minus 53 over 2. So what is the semi-interquartile range? The semi-interquartile range is 80 minus 53 divided by 2, which is 13.5. That's the semi-interquartile range. If you want to know how I found out these, think of it this way. After you reach the middle number 0, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Think of it as splitting the data in half right here. All right, you split the data in half. When you split the data in half, you have 15 terms here and 15 terms here. So to get the Q3, just find the median of these 15 terms. So you go 1, 2, 3, 4, 5, 6, 7, 8. So that's how you get Q3 to be 80. To get Q1, you have 15 terms here. So find the middle term of these 15, which would be 1, 2, 3, 4, 5, 6, 7, 8. That's how you get the semi-interquartile range. Finally, it says 2 students are chosen at random. It says determine the probability that both scored less than 50 on the exam. So the probability that both of them scored less than 50. So the probability that the students grade, both of them, score is less than 50 is going to be equal to, so this is V now, probability that the student score is less than 50 is going to be 1, 2, 3. There are 3 students that scored less than 50. Probability that the score is less than 50 is 3 out of 50. All right. That's the probability of a student's score being less than 50. Well, that's a probability of 1 student getting less than 50, and it said 2 students, so let me call this S2. The probability of both students getting less than 50 is the first boy getting less than 50, and when you take out that boy, you have 2 over 49. All right, so this is the probability that both of them get less than 50. So in reality, it's 6 over whatever is 50 times 49. 2,450. So that's a probability that both of them get less than 50. So it's pretty much saying it's very unlikely that 2 of them get less than 50 that are chosen. All right, let's go now to question 8. Question 8, it gives us a particle starts from rest. It says a particle start from rest. A particle starting from rest, and then it accelerates. Particle starts from rest and then it accelerates uniformly to 20 meters per second in 5 seconds. It continues for 10 seconds. It then accelerates again uniformly to 60 in 5 seconds. The particle then decelerates to come to rest. Draw the velocity time graph. So let's go to the graph paper and